Okay, so we're going to focus this morning on thinking about modularity. Again, this is the theme of the past few weeks. How do we break down programs into smaller pieces? What we're going to focus on is thinking about the way that we've been writing our routes at the moment. And we have a few different objectives. First objective is to explain the benefits of modularizing our route handlers, to actually then do so, and then thinking also about another way that we can store application data. So yesterday we had a quick run through using scope, trying to find a way to keep data at a higher scope so our application can use it. And today there's going to be a better way to do this using the property locals on the app object. We'll have a look at how we do this. So these are our three different objectives. And as always with these kinds of sessions, please make sure you've already updated this repository, because there's been a few new things over the past few weeks that have been added to it. So make sure that this is the most recent version, and then you can navigate to this directory, and first thing you should always do is make sure you install all dependencies, and you can run the application as indicated. So before we dive into what we're actually going to do, we'll think about what problem does this help us solve. So in general, when we're trying to think about modularity in programs, we're trying to achieve a couple things. One is reducing cognitive load whenever you read a bit of code. All right, so rather than have everything in one huge file and a bunch of state that you have to keep track of and different things that might manipulate it, and you have to just try and think of everything. And we're breaking things down into small things, so you only have a little bit to focus on at any one time. All right. So one is readability for everyone else who's looking at your code, readability and maintainability. And the other part is keeping state in the right place. So you want to be able to make sure only use as minimal as possible state in the right place. So rather than have everything that's available for all parts of your application, you want to put it into the right little box, and only the thing that needs it has access to it. All right. So thinking back to some of the work that we did on encapsulation. So we're going to use the same approach, the same idea when we're thinking about different parts of our Express app. And this is one way we can do this. There's a bunch of different places we can apply this thinking, and you should be thinking about applying this thinking to all programs you write in all aspects. And this is how we can do it for our routes. So before I actually sort of demonstrate a very simple example, I want to bring back to sort of that diagram I used yesterday to think about what kind of end state we want to end up with. So this very hastily drawn diagram yesterday was a sort of an attempt to describe scope. That outer purple box is the node application. And I think I remember saying that when we run our application using Node, it goes through and requires Express, and then sets up the routes. So everything that's in this file at the moment could be considered in this purple box, the Node application. Right? You can store variables, you can create your own functions and classes and keep them at this layer. So pretty much exactly what is happening here. I'm inside of this directory. It's a version of the battle app that you've been doing. And so this is not part of the Express app. This is part of the Node application. All right, which is why we're thinking about the difference between what is available in the Node app and what's available inside of the Express app. All right. So all these require statements up here, this state that's being set, all these things here are available because they're in the outside purple box. all right? And they're all set at a scope like var1 is here, all right? So anything inside of this, anything inside of the app has access to these variables. Now, this inside purple box, the Express app, is anything that's inside of this app object. So all of these properties are part of the app that has access to it. All right, so this is trying to get closer to this purple box here. Anything that's inside that Express app is here. So this app is defining a specific route. As we know, it describes a way to execute logic that matches a GET request at the index, and it executes this function. So this would be one of these little inside boxes. All right. Now think of this is a very small application that has 1, 2, 3, 4 different routes. Think of an application that has a lot more than that. This file will start to get very busy. You end up going from 40 lines to hundreds and hundreds of lines. All right, and in general, whenever you feel like you're having to add loads more lines in one file, that should be a signal that you should find a way to modularize this, split it out into a different file. Right? If you have to scroll a lot to look at all the code on one page, it means that there's something that you can do to extract some kind of behavior into a different place. All right. So what we're going to try and do is go from an approach where we have our individual routes like this with all the logic here and everything in one page called app.js. And I'm going to try and split it out into something that looks a little bit different. Still very similar, but with a few more boxes. So I'm going to try and draw a competing picture here. So we're going to still have our node application. Inside of which we're going to still have our Express app. But rather than have these boxes hanging out all by themselves, we're going to put them into other boxes. So we might have an area of our application that handles, let me make this a little bit bigger so we can fit more things inside of it. And this box might be anything to do with the game. This is going to handle any logic that affects the state of the game. And so inside of this, we're going to have maybe these two things. So these are the specific controller actions for making a GET request, a /name, and this one is making a POST request, for example. How you organize them is entirely up to you. And maybe we'll have another one over here where this is going to be something to do with just showing the index. And this controller is specifically for getting the index. So we're going to try and compartmentalize them, all right? In a typical encapsulation fashion, we're putting things into boxes, all right? Trying to organize our application better. And to avoid the problem where we have all these small boxes, imagine you had 100 of them all within the Express app, they're not very well organized. All right, so we're going to try and essentially go from, I don't know, sometimes people see this as a tree picture, rather than have loads of different objects all available on the same level like this. We're going to try and create a slightly different structure so it's a little bit easier to understand where things are and what things have access to each other. So where possible, we try and go to this approach. All right, having everything available or having things encapsulated in the right place. E.g., this is just a rough diagram to get you to think about. This therefore has access to everything here, whereas this one here only maybe has access to this thing. All right, in terms of what scope, what's available to it. All right. So we're adding a little bit of complexity in the way that we're describing or the way we're organizing our code, but we also reduce complexity by thinking about where things should lie and what has access to other variables in that particular scope. So usually when we go through this session, it's a trade-off to begin with by adding complexity by going through this process, because usually when we first start out, everything's a lot easier just to see in one file. And we're going to try and break this up and put it into different files. All right. And so we're going to practice this again in the way that we've already seen us using class extraction a couple of weeks ago, and sort of component extraction, trying to take components out of other components. Same process, right? We've already seen this technique a bunch of times. We're just trying it again in a different way. All right. So let's have a look at a very simple example. Here are those individual controllers for the roots. They execute a function depending on what a request is happening. All right. And what I want to do is to not have the logic of what's actually going to happen here in this file. All I want to do is route it to the place that's actually going to have that logic. So what we're going to do is we're going to create a new folder called routers, or roots, you can call it. And in this folder, let's say this will describe anything at the index. And what I want to do is move this logic. I'm going to comment it out and put it into this file here. Now, given that we're working in Node.js, we have to always think about exporting and requiring requiring things. So if I keep this open on the right, we can actually see the process that's happening here, and let me move all the faces out the way. Is the text too small? Should I blow it up? Can you all see it okay? Thumbs up. Okay, just shout out if you need me to enlarge the text. So the process we're trying to do is this, we're going to put it in its own box and require that box into my app.js. So what I want to do is say something like require, and then we're going to go into the roots directory and get index.js. Right, I'm going to build this in a second. Whatever's going to get exported from this, I'm going to do something like app. I think I'll have to look at the documentation in a second because I never remember this off the top of my head. This one here. So this is in the main app. We've required my my other router, and then I'm going to do something like this. So app.use, and then any request that gets sent to the index, I want you to use my index router. That's all this now becomes. All right. So I've moved this logic over here. We'll fix this in a second to say, well, what exactly this needs to look like. But I've gone from actually having the logic in my app.js, this function here, that executes the response with completing the request by sending back the response by rendering that index.js EJS file over here. This all gets sent back. So this logic is now going to be over in this file here, in this roots file. And in order to make sure this is doing what it should do, let's go back and have a look. We've got to make sure I guess I should always use const rather than var. And then use my router. Cool. So that process was to look at this route here that matches any GET request at the index and saying, okay, I'm going to create a router for this for any request at the index, and I'm going to require it and tell my app any requests that match this, use this specific router. All right, anything to do with this index now gets matched with this router. So you now have a choice what other routers to create, and the instructions of the session here says extract an index router like I just did, then extract a game router. So both of these routes here will be in one router. They are both making requests to /game. So do the same thing, but put both of these inside of that router. And then one more for this turn controller, a post request to turn. All right. And this is practicing trying to extract routers from your main app and requiring them in and using them accordingly. So you should end up with 3 different routers in this directory, and then requiring, you should end up something like this. Or whatever you want. All this should be transferred over, and you should end up with as you might expect. All right, so this is where you should end up with if you manage to extract your routers appropriately. Yeah. So now your app.js, all it does is be the first place where it sort of tells you where to go next and what part of your application will handle any of these kinds of requests. So these are better encapsulated routing behavior. And we'll keep all of them in one directory called routes over here. Now, so I've shown you the process of taking one route and extracting it. You'll do the same again using these 2 different routes and putting them, the 2 game routes, you'll put them into one router and again with a third one. But in order to do this, you'll need to think about where do you store the state of your game. Up here, we require a couple of classes. I'm going to instantiate battle. This shouldn't be hanging out in state here in the top of the app.js file. You can definitely require the classes, but to instantiate it on line 10, we've got to find a different place to do this. So these 2 should also move to where they're required. They're no longer required in this file, but they will be required in probably the game class. So you make sure that you move those over to the right place, and therefore this should also move to the right place. We shouldn't keep it as a global variable. We should keep it as an app variable, an app local variable. So the way that we can do this is by looking at this resource down here, express app locals. And it's as simple as finding the app locals object and adding new properties to it. And anything that you set on as a property for app locals, you have access to in any request. So if you were to, let's uncomment this out for a second so we can play with it. If I were to say for example, I want to store the names of the people playing this game. The app comes from the request, so we always have access to the app called using request.app, and you can set the locals, say I want all the names accordingly. So I've set the names property on the app's local, and I have the app always as a property on the request. All right, this will always be the instance of the application that you have access to in any of the requests. So this is a way to use the app locals object to add data that you want in between requests. And this is now local to the app rather than up here, which is local to the whole node application. So we're trying to go from this green box up here and moving it into a lower scope. And where possible, you should always find the minimum scope that you need. So this is now going to move from here into the Express app. All right, we've downgraded the scope from the node application into the Express app. And where possible, scope should always be as minimal as you can. So the way that you can store it is by just using the request app, the locals object, and then storing new properties as much as you want. And then you can always extract it via the same property in a different request. If this has been set, it will just give you back the value. All right. So use, oh, I'm not sure what happened up there, but. What was it before? Something like this, locals. Yeah. So you can set in one request and read it back out in another request. And you'll need to do this to be able to make sure you have access to the state of your game, because you don't want line 10 to be in the node application. You want to only be in the Express application. All right. What else was I going to mention about this? Finish this part off. We need to make sure we export the router. And anything else in the instructions that I wanted to go over. Your test should not fail. All right, so we're not changing any of the behavioral applications. So make sure you run the tests. Start the application in one terminal shell, run your tests, and then run your unit tests. All these should still pass, no matter how you refactor your root handlers. All right, we're not changing any behavior. So make sure you run them first, and then when you feel like you've finished one extraction, run the tests again to make sure they're still passing, and you should go through 3 extractions to make sure you've taken out all of those routers. Okay. Quick Q&A before you go off and do this yourselves. Does the objectives make sense? Do the objectives make sense?
So you were saying, I'll go first. Thanks, Ramiro. You were saying we should be instantiating the class the first time we come across it, like within the different routes.
Mm-hmm.
Okay, cool.
And you make sure you put it in the right place, because you don't want to suddenly be creating lots of new instances of battle. It should only be created once. So what is the request that, which request only happens once in the life cycle of that user journey? All right.
Yep, cool.
If you suddenly go back and recreate the battle, you lose all prior state, right? So make sure you put it in the right place.
Unless you want to recreate the battle. Sorry, go on, Ramiro.
I just keep getting interrupted. If you go back on the code, how do you put if you want to use 2 files in one router, how would you go about that?
And can you clarify what you mean?
Do you have the code still? So I can.
No, I made it disappear.
So if you look at it says when you did const index router and you required the router itself, well, you required the router, it says roots here there. Say if you wanted to put two things in the index file, then how would you put another
What
one?
two things would you want in here?
Maybe not that one, but say if you had two buttons and you wanted one to work one time and another one to do something else, you would need two posts, wouldn't you?
Keep going. Keep going. Trying to explain this. I think this is interesting.
I might be going off on a tangent or something. Like it seems like this ratio between the index.js file or the JS files in the roots and also the routers themselves, it seems like a one-to-one thing. But I want to put more files into one router.
You don't necessarily put more files, but say, for example, can you see these both with the same path here, /game?
Mm-hmm.
I want to put both of these in the game router.
Mm-hmm. Okay, so I just put them in. It should work fine.
Yeah, in the same way that this is happening, we require express. We create an instance of a router, and then we describe its routes. So you just move both of these into its own separate router. Make sure you use the router rather than an app because you don't have access to the app. And then you export that whole router, which has those two different available routes to describe, the post and the get. And then you tell your app to use that router accordingly.
Yeah, sorry.
Yeah,
I get it now. Yeah, I just got a bit confused earlier, but it's fine.
Something that may catch you out is be very particular about the way that the names of the paths build up. So if in your app.js you describe what router to use at /birds, and then your router says /about, you actually build from here, birds /about. So in the same way that this describes a route at the index, it's not the index at /birds. So /birds is, so you have these two available routes, all right? So whatever you define in your router is built on, in terms of the paths here, is built on top of this match first. All right. So it's not enough to simply move these two over, because if you're already describing /game, when you move those into router, you have to get rid of the game because it's already part of the first match, right? Just pay attention to that.
So if I understood that correctly, if there's two buttons that point to the same page, they should both be in the same router place, in the same file.
What do you mean by buttons?
Yeah, what do I mean? I guess like forms, when you submit a form and it goes to a certain place.
Yeah. Okay.
Because we obviously doing it yesterday. We thought there must be a better way than having a new route for every button.
And at the moment, every form submission sends a request, and you can have those requests pointed towards any different URL that you want. But whatever they are, you have to actually handle it on the server side. So you can have a number of different forms all pointing to this same route if you want to access this logic from different places over on the client side. So it's not always a one-to-one. You might have a couple in different places on your on the browser, different pages that always come back to, for example, this route. Does that answer your question? I'm not sure if I answered your question.
Yeah, I mean, I was sort of thinking the point of having two different. I guess it's I could almost ask Ramiro, but with the point of having two different things in the same. I don't know what it's called now. like where you're putting the actual logic of the router into a different file.
Yeah.
But you have two different bits of logic within the same one. That's because they're both pointing to the same router. Is that the motivation behind putting two different things in the same?
Because great question. I think what you're trying to say is like, why put these in the same one together?
Yeah.
Yeah. And the reason for this at the moment is because they have the same URL. All right, it'll be whatever is the domain/game. Right, they're different requests because they're matching a post and a GET request, but they belong together. All right, this is part of your application that's dealing with the game itself.
Yes, but and because they have the same like root/game, that means they're pointing to the same place, right? They'll take you to the same page.
The different requests, so the post request, when you make a request, a post request to /game, a post request was usually, we make it to submit data. Usually you submit a form with form data. And so we can extract the data from the request body, take those names, and then update the state of our application. So this stores the names in our application. Then it does a redirect to /game, which executes this request, and does things with it. All right, I think this was new, this is added. So it gets the player and then just shows the state of the game at the moment.
Okay, I need to like play around with it to sort of understand.
So like a get and post request to the same page could show two completely different pages.
Yeah, they are the two individual requests, so you can handle them in any way that you'd like. They can do exactly the same thing, they can do different things. But the match is different, right? Because the signature of the request is different. One's a post, one's a get request. So if you want to handle them, you have to have two routes like this.
And is it common practice to have them both in the same directory, or is it
It should be
directory, I mean file, or is it like if they get really big, do you then split them up?
You should always organize them in terms of really the resource that's being operated on, and this is the game object. And it's all the battle objects. So really, if we're in particular, maybe it should be actually called battle. So you organize them first by the URL, which really you organize the URLs by the resource that you're working with. So I'm trying to manipulate the state of the game at the moment. So I'm posting, creating a new game, and I get the current state of the game.
Okay, cool.
Would the app.use get both the post request and the get request if you just use it once?
Say it again, Mira.
Would the app.use, when you use that, would it return the get request and the post request, or would you have to specify which one?
Good question. So you're just telling your application to say any request that matches the index, use this router. Any application that matches /game, use this router. And so it depends on what's in the router. You can have as many routes as you want within an individual router.
Okay.
Cool. More questions to make sure you feel like you know what your task is over the next 40 minutes. Cool. So these two main resources will help you to think about what you need to do as a reference point. And 40 minutes, we'll see how far we go with it, and then we'll come back for a Q&A at about 11 a.m. All right. Stop and